if we've got a triangle, we're going to draw one out here. Let's say we've got this as our triangle. I apologize for the sloppy, not straight lines. Let's say that side length is going to be 20. This angle, let's make this 35 degrees. And let's get ourselves another angle. Let's say that this is 103 degrees. Now, if I'm given two angles in a side, let's move forward with this, but let's give ourselves, let's go ahead and label these pieces here. I'm going to call it 103 degrees. We'll call that angle A. We'll call this angle here that we don't know angle B, and this will be C. Now from that, I know that this 20, which is opposite the 103 degrees, has to be little a. And what I would like to do is I would like to find out what are my two missing sides. What is my little side B? What is my little side C? And what is my angle B? Another way that you could often see this rather than given the triangle diagram is by given all three pieces over here. And we could fill in what we know. We know that angle C is 35 degrees. We know that angle A is 103 degrees. And we know that side A is 20. Obviously, if I know two of the angles, I know the third angle. I can add up those two. We can take 103 degrees plus 35 degrees. And we could take that and subtract it from, let me take that there, move it over just a touch. So 180 degrees minus that. When we subtract that from 180 degrees, we're left with that third angle, which in this case will be 68 degrees. So we know all three angles. But to get to the other two sides, we need to have some kind of relationship that puts that all together. And that's where the law of sine steps in. The thing that we need in this case, in the law of sines, we've got three pieces to that formula. We're actually going to only work with two at a time. And the two that we're going to use depend on what we want to solve. In this case, in order to use law of sines, I have to know a pair of something. In this case, and when I mean a pair of something, I know both A's. And what that allows me to do is it allows me to set it up by saying that the sine of 103 degrees divided by 20 degrees is going to be equal to one of those other relationships. Now it's just a matter of what do we want to go after and solve. Let's say that we want to go after the side B. It doesn't matter which one we go after first, but we'll go after side B. So in order to do that, we'll use sine of A divided by A and the sine of B divided by B. We will not use all three at the same time. So I've got the sine of 68 degrees divided by little b, in which we don't know. What the law of sines is saying is that this relationship has to be true. So if it has to be true, we can go about our way and solve it. To solve this, cross multiply. So we'd have b times the sine of 103 degrees is equal to 20 times the sine of 68 degrees. Now I'd hold off on throwing out your calculators and typing all that in right now, because the sine of 68 degrees is going to be some decimal number that you're going to have to round, as is the sine of 103 degrees. Instead, let's go ahead and keep on solving. I want b, so I'm going to divide by the sine of 103 degrees on both sides. Now the sine does not cancel. That certainly can't happen. But what we can say is that b is going to be equal to 20 times the sine of 68 degrees divided by the sine of 103 degrees. If we type all of that into our calculator, try to avoid rounding anything, you can just type all of that in at once. We end up coming with a value of b as, and it's going to be a decimal, but 13.33. We'll say 2 decimal places. So unless you're told otherwise, 2 decimal places would be fine. So we've got 13.33 as our value of b. To get that final piece of the triangle, I want to go after little c. Now, we've got a couple pairs of pairs. In this case, we've got the pairs of a's, and now we have the pairs of b's. But we've talked before about accuracy of answers and rounding of answers, and I'm going to stay away from the pairs of b's. If I don't have to use them, that'd be great. In some cases, and this will be the case in the future, I'm not going to be able to avoid it. I'm going to have to use a rounded answer, but if I can not use this 13.33, that'd be great. So we can go back to our a's and say that the sine of 103 degrees divided by 20, and now we can use the relationship of the c's. I know that the sine of 35 degrees divided by little c. We have no idea what that is, but we can divide by c, and now we've got another proportion that we could solve. To solve a proportion, cross multiply. C times the sine of 103 degrees is equal to 20 times the sine of 35 degrees. Not going to type that in yet. C will equal 20 times the sine of 35 degrees, and since that's a product over there, to get that little c all by itself, we'll divide by the sine of 103 degrees. Type that all in. We end up with an approximate value of c of, I believe I got 11.77. And we've solved the triangle. Now let's check and make sure that we got this. I know that all three angles add up to be 180 degrees. A, B, and C, I could take the two shorter sides. If I add those together, they come up to be bigger than my long side. So that's going to be true. The other thing that I know is going to be true, and what I wanted to look for here is, take a look at the relationship between the angles and the sides. My largest angle is paired up with the largest side. My smallest angle is paired up with the smallest side. And my middle one is paired up with the middle one. That doesn't quite tell me if all of them are exactly the same, but it's a good indication that we went through and did this correctly. And we solved our triangle. Now we could also do one other thing. We could take that area formula, and we can say that we could show that all three pieces hold true, but we'll get back to the area later. But for right now, solving the triangle, there we go. So here's what we'll do. We're going to give you another problem here. This time I'm going to tell you that angle A is 51 degrees. You don't know B. Angle C is 63 degrees. Little a, you don't know. Little b, you don't know. But little c is going to be 13. So here's what I'd like for you to do. If you could pause the video at this time and see if you can go through and solve the missing three pieces. When you're done, when the class is ready, go ahead and hit start, and you'll check your answers and see if you got everything okay. If you want to draw yourself a picture with this, we could say A, B, C. I know I've got 51 degrees, I've got C is 63 degrees, and I've got little c being 13. So if we go ahead and start solving, we do have a pair to work with. We have the sine of 63 degrees divided by 13 is going to be equal to, I'm going to go after little a first. So the sine of 51 degrees divided by little a. Cross multiply. Divide. And plug that into our calculator. I hope you came up with 11.34, approximately. To get angle B, I know that I can take 180 degrees and subtract off the sum of 51 degrees and 63 degrees. Angle B comes out to be 66 degrees. To go after that missing side then, the part that I know, the part that I did not round, the sine of 63 degrees divided by 13 is equal to the sine of 66 degrees divided by little b. Cross multiply. I'm losing my pen here. B times the sine of 63 degrees is equal to 13 times the sine of 66 degrees. Divide. And come up with an approximate answer of 13.33. When we check our answers, we've got our largest angle and the largest side. We got the shortest angle and the shortest side, and the in-between and the in-between. We also notice something, 63 and 66 degrees, those angles are pretty darn close. It should go without saying that the two sides are going to be very, very close to each other as well. All right, one other problem to check, and let's see if I've got, if I can do a copy paste here. All right. Should have been a little more prepared. All right, copy. We'll send it over here. Okay. A golfer misses a 14-foot putt by putting 5 degrees off course. The hole now lies a 124-degree angle between the ball and its spot before the putt. What distance does the golfer need to putt in order to make the shot? Once again, if you would take down the important pieces of information that you'd like, you can pause the presentation for just a moment and see if you can solve the problem, answer the question. In this case, it's going to be helpful to draw a diagram so we know exactly what it is we're looking for. So I'll give you a moment to pause, and we'll come back with an answer. All right, to draw yourself a picture, said that we had a 14-foot putt, and it was 5 degrees off course. Now, one thing that I don't know about this, I don't know if they hit it past or if they hit it too short. But there is a little bit of a clue. It says that the new hole lies a 124-degree angle between the ball and its spot before the putt. If I extended that line all the way past, if I shot it past the hole, the angle that gets created, that certainly cannot be an obtuse angle. That's too small. But if I look at the angle that I made too short, that certainly is an angle that's bigger than 90 degrees, so that could be my 124 degrees. So I ended up not shooting far enough. Now it tells me that I was 5 degrees off course, so that means that I've got a little angle, 5-degree angle inside here. So I've got 124 degrees between the path and between the ball and the hole. 14-foot putt. Missed it by 5 degrees. We need to find out how far is left, which means that we want to find out this length right here. Without going through and labeling the triangle, and we certainly can, what I want to do in order to find the missing piece here, since I know an angle and a side, an opposite pair, I know that the sine of 124 degrees divided by 14 is going to be equal to the sine of 5 degrees divided by x. If you can get yourself set up there, you're on your way to solving the problem. Cross multiply x times the sine of 124 degrees is equal to 14 times the sine of 5 degrees. And one other thing I didn't mention, I would like to see as you're going through, if we're talking in degrees, please make sure that you're writing that degree sign down. X is equal to 14 times the sine of 5 degrees divided by the sine of 124 degrees. That sign does not cancel. And you end up with an x value after you plug that all in as approximately 1.47 feet. So just to tap in. All right, so for your homework, problems to practice, page 298, numbers 1 through 9. You'll have several of them where you're just solving the triangle, and you'll have a couple situation word problems to work with. Hope you all had a great day, and we'll see you on Tuesday.